Thank you very much, Sarah. Can you hear me okay? Yes, perfect. It just took a second. Thank you very much, Sarah. We will now move on to our first session of the day, which has the theme of resilience. So we will have 3 different talks about very different topics within this theme. So I'll just go ahead and introduce our first speaker now. She will be, she's already joined us on that screen at least. I'd like to introduce Eleanor O'Rourke. She is the director of the CMIP IPO, which stands for the International Project Office of the Coupled Model Intercomparison Project. So she's got lots of experience in climate research as well as policy making. So she'll be discussing today how Earth observation and kind of space data can help us foster climate resilience. And I will stop sharing our screen. And hopefully, Eleanor, you can now share your screen.
Yeah. Just let me know when you can see it.
Oh, yes, perfect. We can see it.
Great.
I'll hand it over to you now.
Well, thanks very much, Dora, for introducing some of the many acronyms in my exceptionally long job titles. So yeah, I'm from the CMIP International Project Office. And today I just wanted to kind of talk to you about how the observation modelling interface, so working together, can really support climate resilience. So just as a start, what is CMIP for those of you who are not familiar, and how does it support climate resilience? So the Coupled Model Intercomparison Project is an activity that sits under the World Climate Research Programme. And the World Climate Research Programme is a sort of jointly funded activity that sits under United Nations and a couple of other co-sponsors. And the aim of CMIP is really about providing climate projections so we can understand the past, the present, and also the future climate changes. So we use climate models and then Earth system models to look how the future will change and how the human activities will impact the future climate. So that's things like the level of warming and the sort of extremes and floods and droughts, etc. When we compare simulations across lots of different models, that helps us understand where results are consistent and where there's perhaps greater certainty, and where the results are much less consistent. So that's things like cloud feedback is a particular area of sort of uncertainty, and sort of other major sort of dynamic systems as well. So CMIP is what coordinates this model intercomparison. So having all of the modelling centres run the same experiments with their different models. Having this multi-model approach really helps us to evaluate the climate models. So it helps improve the simulations and drive the model development, and also gives us that better understanding of the past, the present, and the future. One big additional strength of CMIP, and some of you may have used CMIP data, is that there's this global infrastructure which brings the data together in a really consistent format and also gives open and free access to anyone in the world. CMIP is also part of what is called the modelling multiverse within the World Climate Research Programme. So this diagram just kind of has these different axes of resolution, ensemble size, complexity, spatial coverage, and temporal coverage to kind of indicate that there's these different types of models. So you have CMIP models, which are climate and Earth system models, which have quite a lot of complexity now. They include things like carbon cycle, but are not always quite as high resolution as some of the sort of high resolution activities that we're starting to see now. But basically, you want to use a bit like your toolkit that you use in the house. You want to choose the best tool for the problem that you have in front of you. And it's the same with models. Different problems need different models. So they're all important and we all kind of need to work together. CMIP is obviously at its core and at the start was really about driving climate science and climate model development, but is becoming incredibly important to informing policy. CMIP 6 was the last phase, and it was like a massive expansion. There was a huge number of the model intercomparison projects, the MIPs. There was 25 countries involved, 131 models, and over 300 experiments. That gave over, I think it's actually maybe nearer 30 petabytes of CMIP 6 data. So there's a huge amount of data available to be analysed. So the kind of questions that are being addressed in the future phase of CMIP are some of the ones that are really important to understanding our climate now and also how it will look in the future. And that's things like patterns of sea surface change. We have the big sort of ENSO, El Nino type mechanisms, and also how those changes are going to co-evolve with those in the poles. We've got the changing weather, our extremes and the dangerous weather patterns. Then that water carbon climate nexus. We've got these big changes within the carbon cycle. How is the Earth going to respond to that? And a really topical one that has come up a lot in recent years is things like tipping points. So what is the risk of really going past that point of no return? And where are these likely to happen? So that's things like the AMOC, the overturning circulation in the Atlantic, or the Amazon sort of drying out completely. So these are really important topics to address. So how do we support climate resilience and informing policy? So CMIP and the infrastructure and delivering the data has really become quite essential to the Intergovernmental Panel on Climate Change, the IPCC, as well as all the other international and national climate assessments that help support, climate policy development, mitigation plans, but also that risk analysis, impact and adaptation planning. The sort of projected climate change in the couple models due to the greenhouse gas forcing has been part of every IPCC report since their inception and since CMIP started. So CMIP data also really drives the downscaled models. So when you take the finding detail on a much smaller scale, so perhaps say over Africa or over a country level, and also the impacts models that look at things like the impacts on fisheries or on agriculture. So that CMIP data is really the boundary driving all of those downstream models. And that especially supports climate impact and adaptation planning, which really helps countries, communities be much more climate resilient. So CMIP, as I said, was originally a science project, and within that, it meant that everything kind of happened at once. There was lots of activities that were coordinated so that everyone was doing the same experiments, but it kind of happened en masse. That, when it became that more and more models and countries are being included, it became a real big burden on all the modelling centres. And it became more difficult to determine what information was really needed on that IPCC policy cycle and what could be kind of generated consistently. So we've developed this new design where we have these fast tracks, and that's targeted at specific needs. So the first fast track for CMIP 7 will be the assessment fast track, which is going to support the IPCC AR7. But we also still have this huge number of community MIPs that are addressing all of these really specific science questions like cloud feedbacks, geoengineering, all of those kind of specific topics that feed back into our full process understanding. So how does the space sector and Earth observations support climate modelling? This is a really complicated diagram, but the main sort of outcome out of it is we've got all of the key stages of Earth system models on the left-hand side as you look at this, and on the right, the Earth observation. And in the middle, you see all of the lines that connect it. They're totally interconnected and dependent upon sort of one another. But traditionally, almost there's been very much an observational community and then a modelling community, and it's how we can bring these closer together. So one activity which also sits under WCRP is the Earth System Modelling and Observations Core Project, and it was started around 3 years ago, and it's to really try and bring those observations and modelling communities together and advance everything across WCRP regarding observations, the data assimilation and the modelling. So there's 3 objectives here, and they're really also looking to bring together these aspects of model observation integrated frameworks, looking at projections of their system, also the understanding of climate system changes and impacts, where we need to look at things like the uncertainty quantification. And that's quite difficult because model uncertainty is different from observational uncertainty. And there's a bit of a communication challenge between the communities to understand what each means by their definition of uncertainty. We also need to look at advancing and harnessing emerging technologies in modelling observations through the use of AI and machine learning. There's a very specific group that's now set up, and Dora is part of that, the Working Group on Observations for Research and Climate. It's ESMO's newest working group, and they're really going to be looking at identifying and addressing the research gaps in climate observation data and act as a facilitator across the sort of research and industry sectors, which is obviously very, like, space is quite spread across both research and industry, whereas some other, particularly climate, tends to often be more sort of governmental or public sector. They're planning some new activities around emerging technology for analysis and the existing model intercomparison projects as well. But they'll also be looking to engage with a lot of the space agencies and the observing networks, the in situ as well, because that's important that we have Earth observation and in situ observations and modelling all working together, and places like the Committee on Earth Observation Satellites. We're also working, we're part of ESMO and in CMIP, and we're also working very closely with WGORG. So just some examples of where Earth observations are critical within CMIP and CMIP 7. So I'll give an example with climate forcings and also our rapid evaluation framework. So climate forcings are really key in defining the sort of external exogenous drivers of ongoing climate change and variability. They're really an integral part of defining the future scenarios and idealized model experiments. So they're really what drives the climate and Earth system models. The forcing agents, they can either be natural, so that's things like solar forcing or volcanic eruptions, or they're those anthropogenic drivers like greenhouse gas or land use changes. We really need up-to-date, accurate and well-documented forcing data sets to build confidence in our model simulations, and also both in terms of attributing the historical changes, but also the projections of future climate change. And observations are a very important part of developing climate forcing data sets. So I just thought I'd show you an example. The volcanic forcing data set for CMIP 7 has been completely updated because there's been some interesting new research. And if you just look at this picture, you kind of can squeeze up your eyes and you could probably see where the advent of the satellite era is. So on the right of the image here, you can see a lot more wee circles. And that just shows that there's a lot more of these small magnitude eruptions being detected. Before the satellite era, you're looking at things like ice cores and other paleo sort of indicators of volcanic eruptions. And without these small and medium-sized eruptions being included, it's been shown that there's a significant effect on the future climate, and that's previously been underestimated. So this just shows how important the up-to-date and emerging observations are to having improved future climate projections. Another great example is supporting model evaluation benchmarking. So that's looking at how we can assess the models, look at verifying them. So are they doing what we expect them to do, validating their kind of process representation. Then also looking at how they match observations, both in terms of a single model or the multi-model ensemble, and then looking at how they sort of represent different metrics and how they may be best used for different global regions, for example. This has become really important because our climate models and our system models are becoming more and more complex. There's more processes being represented as the resolution increases, things like the carbon cycle. So we need different observations and new sort of observations to compare with. So the rapid evaluation framework was developed by the model benchmarking task team within CMIP. And the idea is that this builds on existing evaluation tools and is a real community-driven platform for benchmarking and performance assessments of the Earth system models. So it's going to provide a complete end-to-end system to give a really systematic and rapid assessment of the models that are going to be participating in the assessment fast track. So this was seen as a sort of need for groups like the IPCC author teams, who we all know they're always against like deadlines. So some of our scientists had said it would be really useful to be able to have quick graphs where they can look at the information in a kind of snapshot and then delve into the analysis. So we have that, the results give us sort of immediate quantitative feedback, and that gives the model developers as well as the scientists, they can quickly see where there's model biases or perhaps performance issues. But the REF is being developed at the moment for the first stage for the assessment fast track simulations, but that's going to be a starting point. It's open source, so it can be developed by the community. And then it can have applications far beyond CMIP to some of the other models types, like the regional models, where they can be used to perhaps help them select which global models they use for their downscaling. It also is leveraging our best available observational data sets, both Earth observation and in situ. And that can then provide the assessments of the model fidelity across the range of diagnostics. So the slides will be available afterwards, and there's a couple of links here that you might want to have a look at. So here there's also a link to where you can see all the reference data sets. Dora did a great job on helping us get a lot of these on board, so they could be included in the REF. And these have to be prepared, the data, in a way that allows for the comparison with model data. So that happens within an activity that's called OBS for MIPS. So it then means the observational data, which is often in quite a different format, is then put into a standard format that can be closely compared with the model output. Sometimes there's obviously not complete one-for-one comparisons between an observational variable and a model variable, but that becomes an important point of discussion between the community. So in terms of kind of just sort of summing up, the climate models we rely on for projections of the future climate, which really help us mitigate or hopefully reduce the impacts, but also plan and adapt for climate change, which really increases our resilience, because if we don't plan for it, we can't be resilient to it. They use Earth observations and the in situ, of course, from the whole process, from initializing the models, their process understanding representation, through to the evaluation and benchmarking. With kind of sustained and more globally representative coverage, the Earth observations have really helped support improved model representation, evaluation and benchmarking across the world, but it's particularly important for the underrepresented regions, places where the models are perhaps not tuned to as well, and also where there's a real lack of in situ or available observations. We really want to strengthen these links between the observational and modelling community so we can really support that downstream climate resilience, and activities like ESMO and WCRP with partners in the space sector as well are going to help drive this forward. So if anyone has any questions, that would be great. Thank you very much.